I think it was about 5 years ago, I came and talked about setting up the course on big data that we called it. And I described the process of creating the infrastructure necessary to be able to actually use MapReduce and Hadoop and Hive and Spark. And that was quite a big engineering sort of effort to get all of that working. There's a sort of an advance on that where I've been able to use one of the vendor's products in it that simplifies a good chunk of it, not all of it, but a good chunk of it. So the course that I teach in our MS in Business Analytics, it's an elective towards the end of the program. So it's actually in the last semester for those that don't have an extension. So by the time I meet them, they have been through a good deal of the analytics content. So they are very familiar with R, somewhat familiar with Python. They've seen machine learning in a few ways and no SQL. So I don't have to teach them those things. So I can rely that they have at least got a base level of knowledge on that. Without that, I couldn't teach what I do in half a semester. So the overall plan, it's a half semester, so I'm like a mini. I've got 7 weeks, and the way that I've split it up, there's 2 big sections. In the first 3 weeks, I introduce them to the idea of big data, the idea that there's many data sets, not just they won't fit in Excel, they won't fit in your laptop, they won't fit in any computer. So web scale data, IoT level of data, you're not going to be able to include it in one computer and analyze it. So the solution is to fit it in multiple computers. So distributed computing, distributed storage. And I go through the principle of how that works in practice, that you need to have fault-tolerant ways of storing data across clusters. You need to have fault-tolerant ways of processing the data. So they understand the basic principles of doing that. We set up a cluster on Amazon's web services. It's called EMR, one of the services, Elastic MapReduce. And there we are able to understand and play with a distributed file system. I get them to do a little bit of Linux. I've got some videos to take them through the very basics of working with that, so that they're able to move data around between distributed systems, upload it, download it, and manipulate it. And once they have those sorts of principles, we switch to using one of the higher level languages so that they understand that they can invoke all of this machinery with a more user-friendly front end, so that they can take their SQL skills and work with it. Some of the most interesting bits are that you're able to do this without having to transform data sets that, let's say, originally came from the log files of websites. We are not loading it up into a database. We are just literally using the log files, and with appropriate regular expressions, you can treat it as if it's a great big database file. We do, as a sort of an example of something that you wouldn't expect to be able to do with an SQL type of syntax, we take some tweets and we do some basic sentiment analysis on it, and they learn about the different ways that we can store data on clusters, the sorts of file formats that work through that. Then, and that infrastructure does work, but it's quite a lot of work to keep it running. Whenever you're having 100 people on it, it can be a little bit fragile. So when I switched to using Spark for the latter half of the course, there is one of the vendors that supports it, that provides a community edition of their software that I'm able to use, and it's got a much nicer front end and set of capabilities. So for the remaining time, I introduce them to the architecture of Spark, which is sort of the MapReduce architectures on steroids. It's much faster. It does a lot of in-memory processing, and take them through to how to use one of the many languages it supports to be able to do basic analytics. So all of the stuff from ETL and slicing and dicing can be done with a number of languages. So I show that everything they learned about in Hive can be pretty much taken over into Spark. I take some of the same code and show that you can run it directly on Spark. It'll just be more efficient. But then show that they can do a lot of the work with Python. So the sorts of skills that we just learned about, they can apply those Python skills to working with these larger data sets. And so once they're comfortable with that, we switch to showing how you do machine learning in this sort of environment so that you could use web scale data to get the sorts of insights. And because I've already met all of the different types of machine learning, I can go through them quite quickly. I do a few examples of the feature engineering, both regression and classification models, hyperparameter tuning, cluster models, geodata, do LDA as well. So there can be showing how to apply this to fairly realistic data sets. Finally, the last session, I introduced them to something that I added in last year, and that's streaming. So the idea that we're not just analyzing data sets that are static, but we're analyzing data as it's arriving. So one of my examples, and I'll give a demo of it if there's enough time, is I used to do it with Twitter, but this time I'm doing it with Mastodon, the actual tweets or the posts coming in, and do some basic analysis of it as it comes in. And interestingly, you can do joins and so on with streaming data structures as well. So the main part I want to talk about is this latter part, and doing it on Databricks in particular. So for those that aren't familiar with Spark, it's I'll actually switch to its website. Maybe just it brings out some of the higher level points. Aha, in the meantime, something has changed. It is there. So Spark is open source. It was originally developed at Berkeley as a sort of a demonstration that it was possible to do the distributed computing in a more efficient way than was supported with MapReduce. People started to use it even though it was a demonstrator of proof of principle. It ended up being very attractive to many people in data analytics because it just worked so much faster than the other methodologies. It's now open source, so you can go download it and play with it even on your laptop. You don't necessarily have to have a cluster. And it is quite powerful in that it can do things across a large part of the sort of data life cycle, from the the basic ETL sort of work or working with data lakes through basic SQL analysis, the more advanced machine learning data science elements, and as I said, it can integrate both streaming and batch applications. So it's pretty flexible. You can demonstrate a lot of the principles in one environment. It is multi-language, so I use Python for most of what I do, but it supports all of these other languages. So some of the students like R, and they can express what they're doing in R if they like. I show that you can take that knowledge in SQL as well. And if you are a harder core programmer, you can do it in Scala and Java as well. And it's a nice, it plays well with other systems. So it integrates quite well with a lot of other environments, and the sort of data engineering at an industrial scale to be able to handle large data sets. So we touch upon some of these things, but it's a very rich environment. You couldn't cover it all in 6 weeks. But it seems that whenever the students are talking to potential recruiters, that the idea that they have worked at least with one or two environments where you understand the principles of big data is attractive to at least some of the potential employers, going beyond working with CSV files on your laptop. So, and it's used by lots and lots of companies. I don't know if they had some of the logos, but it's one of the most commonly used big data tools in industry. And they get an opportunity to understand what's going on at different levels, so we can build upon what we understood about distributed systems to understand what's different about Spark than some of the others. So we can do that. We talk in principle of how the execution engine works and how it distributes the processing across potentially thousands of different processors in a cluster. We spend a good bit of time then on the higher level languages, where it's called Spark SQL, but it really is using data frames. So similar to the data frames that you would use in R or use in Python, except they are being, the processing is being run on potentially hundreds or thousands of machines. MLlib, machine learning library, is modeled on scikit-learn, so it's not code compatible, but if you've learned scikit-learn with Python, then you'll be able to read the code at least. You'll be quite familiar with how it works, and it supports pipelines. You can do graph processing. I don't have time to do it in this class, but I have included at least one session at the end to start to show that you can use this same infrastructure for data on the move as it comes in. And that's one of the messages about big data, that is, you've got the 3 V's of big data. So one is volume, but the second most important one is velocity. You cannot wait for it all to be in a static data set to analyze it, because the value may have disappeared. You need to process it as it is coming in. So we at least, they are then familiar with the concept, and it makes good business sense. And then they can at least start to play with some of the basic examples that we've been doing. And as I said, we work with multiple languages. I actually use the community edition of big data, so of Databricks, so we can actually use that for free. Anybody can go and use their email address to set up an account. That makes it a little bit, I think, quite a lot easier. I've spoken to some colleagues that use their paid account, and you can get free AWS credits for the processing to have larger clusters and for more storage. But it's a big jump from the community edition to using the paid edition. There's a lot more to manage: accounts, expenditure, and always apparently running out of AWS credits. So it's a bigger task to take on to manage that. So far, I've been able to work quite well with the community edition. One thing that is lacking there is there would not be enough storage for medium-sized data sets on that. So we actually use Amazon's S3 distributed storage for the data sets. And it's not that difficult to set up the student accounts. So we have our own S3 account. We can set up in a script 150 student accounts and TA accounts and my account. So all of the students can have both read access to the data sets we're using, but read-write access to their own buckets. So they can store results, store their own data sets for the work that they're doing. And that makes the community edition feasible with using sort of fairly big data sets, non-trivial data sets to work with.
Quick question.
Yes?
In your exercises and others, you actually expose them to larger data sets that allow them to really see the need for big data?
So on both of the early set of data and a later set of data, it's in the hundreds of megabytes level. So you could do it on your laptop, but it also means we don't have to wait a couple of hours for the results to come back. So there would be a trade-off. I know some, I get on some calls with others that use Databricks and similar technologies, and some of the professors do use really big data sets, like hundreds of gigabytes or even into the terabytes. The thing is, with a reasonable sized clusters, this will take hours and hours to come back. You're using up enormous amounts of processing power, particularly if they keep making mistakes. So, right, depending upon your objectives, if the learning objectives is just to learn how to use it, how to do it in principle, you don't need to do it.
The reason I asked, I always struggle. You teach all this stuff, why do you need it, and what
Right.
then by the time you go to the examples, other than the code, which is PySpark or whatever,
Right.
it looks like this and thing, like, that's why I asked.
Right.
I don't know what the answer is, but
Yeah. So, but I guess it's I will then talk about that the quantity of log files are such that they would not work on your laptop, but the samples that I have would. Right. Yep.
I guess in your architecture, you start with an Amazon EMR cluster.
We do.
And then all students log into that same cluster.
They do.
Running it simultaneously.
Yes. We actually have 2 clusters to spread the load a little bit, but yes.
And what sort of interface do you use? An Jupyter-like interface? Or?
So right at the beginning, we use CLI just to show that they can do it. They can run code from the command line. And then we introduce them to a notebook format called, there's not actually Jupyter, although it is available, a Zeppelin notebook, right? So that's possible to do that. But I'm a little bit wary of only doing that because then it doesn't look different than your Jupyter notebook on your laptop. Yes.
comment about whether we require something like PAN to analyze the data set. What would motivate PAN or something like that is to emphasize that it brings in a certain degree of interactivity with the program, faster feedback loop, as well as
Right. Right.
that may not be present when you are looking, analyzing it using just one laptop.
Right. Right. Yes. Yeah. So certainly the part of the benefit is not just that you can fit the data, but then you've got in principle 10, 100, 1,000 processors working on in parallel, so you can get results quicker. Yes. Okay, so got a few little questions there, and thank you for that. Okay, so I think I've done that one. If you want to get up to speed with Spark, I found these 2 books to be very good. Some of the older books were based on early versions of Spark that were, really were deep down techie ways of interacting with it. But I found that this book in particular hits at the right sort of level for MSBA students. It's not too technical, and it focuses on getting results. It has code in Python as well as other languages, whereas some of the older books it was only in Scala, which was a sort of an obstacle to understanding what was going on. And as I said, I use Databricks. So that was actually set up as a commercial company by so the founders were actually the lead authors in the first versions of Spark. So they, out of Berkeley, and then they commercialized it. And this is the front end of it. So a nice thing about it as well is it solves the Mac and PC problem in that it's all done via the web. You log on and it doesn't matter what sort of computer you're basically using. And I can share notebooks with the students and they can run the code that I run. And the assignments that I provide them then are basically extensions to what I had in the notebook. So we went through, we analyzed some data sets in the notebooks, but then we can switch to their hands-on opportunities to do the same sort of analysis on a different table, or we can do extended analysis on the data that we've already been working with, and that can be both the basis of in-class activities and homework exercises. Right, so that's, if we have, do I have a minute or two? Yeah, I can just demo quickly what the front end looks like. So I opened one later. So this is actually the streaming example if my cluster is still up. So, so it looks just like a Jupyter notebook. So I'm able to install packages and set everything up. So this is actually listening to, I ported some code from Twitter to this new Mastodon posting network, partly because it took Twitter a long time to get back to me with new API keys. So that, because I think they've had a little bit of difficulty recently. So. All right, so I think this is, so I'm basically listening for posts coming in. I included Trump as some of the terms to look for, hoping that will create some traffic. And this simple example, I listened to that, to the purely the text from these posts. And when it starts coming in, let's just check if something. So I'm starting to get posts coming in there. And it takes a little while. So this, I can set it up and it takes a couple of minutes to set up, but in principle, this job could then be running for months, streaming in the data there. And you can actually see that even though I end up expressing the queries using the same language as we do for batch data, there's a huge amount of different sort of engineering going on underneath. It's one of the cleverness aspects. So I have this going on, that the code that I actually use for working with streaming data, it looks exactly the same as for batch data. It's that the execution engine takes care of all of the complicated details of working with streaming data and hides it from the analyst. So if you learn how to handle the batch data, suddenly you can use 99% of that on streaming data. And this simple example just allows me to do, the first sort of big data, the equivalent of hello world, to do word count, right? So there's not too much going on, but there's a little bit going on. So I can start to see what are the common things that are being talked about in the particular subset of posts that I'm looking at. And every time that and here I'm just using an SQL query for this, but the table is changing as new data comes in. I don't know if it'll. All right, so I think that's the demo part of all. And then in terms of having some resources that you can use yourselves, I've posted my syllabus as a Google Doc. So on that, you can sort of see what we cover. And included in that are some instructions for setting up a free Databricks account, and how I cover getting started with Linux and those sorts of things. So I think that's, and Databricks also offers a university alliance, so you can sign up and they'll give you, support. They'll open up some training materials for you. Yes?
So, what you just showed the demo, basically that's just Databricks as expected, but in the back end it's Amazon doing what?
Yes, well, the way that I've set it up, it is running on Amazon Web Services. It's not on EMR. It is Databricks running their system on top of Amazon. Yeah, I have one. The way that I do it, it's a one machine cluster, but if you pay the money, put down your credit card, you can open up hundreds or thousands of machines on a cluster if you like.
So what is the value add of Databricks? It's just a Spark is open source software.
Right. Well, they're doing all of the engineering of installing it in an automated way across tens or hundreds or thousands of nodes, and doing all the plumbing to set it up. On demand, right? So if you have a job and you want to work on something for overnight to work through several terabytes of data, you can set up the job, run it, and then free up those machines. You will have only paid for those machines for the time that you need to do the processing.
Okay.
Yeah.
All right. Thank you very much. We can take. I saw there's one more question. We can maybe talk about this offline.
Okay.
All right. Thank you.